One of the perks of being a YouTuber with a fairly large base of followers now, and I think at what I'm at now, I'm around 76,000 or so subscribers, is that I get companies that send me products that they'd like me to demonstrate and show off. And some of these products have been some have been kind of cool. I've had power supplies, cameras, DVRs, projectors, all kinds of neat gadgets, lots of dash cameras. And then I get ones like this that you just have to see. We're going to open this thing up. I haven't even looked at it yet, but it says it's a touch control table lamp. And looks like it's got color control, brightness, and can probably do all different colors. Yep, looks like it can change color. So let's open this thing up and just take a look at this lamp. The link to this will be in the description. So say these are unsolicited. I just get companies that contact me and they say, hey, we'd like to send you one of our products to show off. And I understand that some of you might get upset with this, but other people do like to see these products, and I'm sure that they probably do help demonstrate the product and sell the product for the manufacturer. So what do we have here? This is kind of probably a power supply. Yep, this is an adapter. So it runs on low voltage. I'm not even going to look at the instruction manual because it looks like they're printed right on the top here. How to use. We have a set of instructions. Plug in. That's step number 1. Plug it in. Okay. Power cord plugged in. Oh, it lights up blue to indicate that it has power. I'm going to imagine that you just touch it and the light turns on. How to use. Okay, here's what you do. Tap the surface to turn, the top surface to turn the lamp on and off, and to change colors. Cool. Tap the top surface to turn the lamp on and off. Okay, that's how it works. It cycles through the different modes. Adjust brightness, long press on the top, and it will adjust the brightness up and down. Color change, tap the top surface to switch the color. Warm white auto cycle of 256 dynamic colors. Lock and unlock the color. Double click on the top surface. Okay, so that's what this is. This is just an ambience light. We're going to let it be an ambulance. We're going to let it be an ambience light. So we tap it, and it turns the light on. If I tap and hold, it will dim down, and it will brighten up. This is more of a mood light. It's bright in here, so you're not seeing the full effect of this because I have the shop lights on. If I shut the shop lights down, you'll get a better idea of how much light the unit puts out. It's like a night table lamp. Tap it a second time, it'll change to a cooler color. As you can see, tap it a third time, and it's going to start changing colors. It's a color cycling lamp that's going to go through all of the different colors, which seems to be the new in thing for ambient room lights. Something like this you could stuff over in the corner or put behind the TV. If you've got a TV sitting on a stand, put this in behind the TV. It'll throw a nice color changing light on the wall. It's like a wall washer. And I actually have that on my television. In my media room, I have a strip of RGB LEDs that run up each side, and they just change color, and they just throw a constant color changing effect on the wall behind it, and it actually looks kind of neat. So this actually is a neat little lamp. I'll have to find some place to use it, but I think I'm going to actually put this thing into service. I know what's going to happen. One of my adult kids is going to grab this and say, "Oh, that looks cool. I want this for my room," and I'm going to lose it. But before I do that, we're going to take this thing apart and see what makes it work. Curious as to how we're going to get into the base of this. I would imagine that somewhere under here there's probably, it's got a anti-slip base, but somewhere under here there's probably screws that hold this thing together. Would not be useful for someone who likes total darkness in their room at night. I know there's people that just cannot have any lights whatsoever. or they can't sleep. Okay, there's screws under here, so this should be relatively easy, I would think, to take this apart. There's probably 3 or 4 screws, I'm thinking. Looks like there's probably going to be 4 screws, so we'll just remove the screws, and the light should pop apart, and then we can examine the circuitry and the LEDs. I'm trying to open this up with the least amount of impact to it as well, to try and get it just where the screws are, so that when I put it back together, the base will still sit on the unit. And there should be one more screw, should be over right about here, I would think. And there it is. Now I don't know whether the top's going to come off or whether the bottom's going to come off, but it looks like it's the bottom. Okay, so the bottom has got a wire that connects all the way to the top. So it looks like there's some tabs on here that we can release as well. That should release the top, or release this base, looks like. Got the control circuit on the bottom with an IC, and it looks like it may be a buck converter. And the top should actually pop off, I would think. Of course, if I remove a couple screws on this whole circuit board will lift out. Okay, now the base is removed. We can actually see the rest of the circuitry. If I unsolder this, this is the sensor lead for the button on the top, the touch sensitive button. So if I unsolder that, then we can actually unplug the circuit board, because it does have a flex cable on here as well. I can unplug the connector, and then I might be able to get the rest of this light apart so we can see what's inside here. It's just going to be some LEDs on here, but I like to take it apart because, you know, that's what we do on this channel. We take things apart. We take perfectly good working devices apart, and sometimes they don't go back together. Okay, there's that wire disconnected, and we'll just remove or unclip the light assembly. We can look at this in a bit. We'll look at that circuit board. Now I want to see if I can get apart the base assembly for this. Looks to be, it's probably just press fit. Looks like there's clips on here. So if I were to push these clips out, I should be able to open this up, I think. And that should remove the base piece. Well, I'm trying something here. We're going to release all these catches at once by putting a screwdriver into each one to release the catch, and hopefully this thing's going to actually open up without getting damaged. There we go. So now the base is separated from the lamp itself. We can remove the base. I expected that this was just going to be a couple of LEDs shining up, but it appears that it has a little more in it than that. So let's take a look underneath this light tower. In the name of science and quality control, we need to see how this thing's put together. And there is the light tower. Now we're down to our LED chips, which we can actually power these things up separately. Like I'll hook it up to the power supply and we'll be able to make it work. It's on a heat sink. They've got some thermal paste on here. because obviously these lights are going to generate some heat, especially the white ones. You've got your colored lights here. Actually, these are probably the RGB ones here. You're going to have, looks like we've got 6 of each of the different white tones. So 6 that are warm, 6 that are cool, and then 3 of the RGB color changing lights. Looks like what it has. Let's plug the circuit board back in, and we'll power this thing up. I guess I can just take it right off of that. I don't need that on, but I do need to keep the dye on the base here. I believe that's the way that the connector goes in. It's either going to work or it's not. If I put it in the wrong way, we might not get any light out of it. I'm pretty sure that's the way it went in, because that board would have been sitting like this. Okay, turn this thing over, and I get my power adapter, and we'll give this thing power. And if I touch and there's the lights. So if we tap, I'm just tapping the sensor terminal here with my thumb, because this is what connects to the wire, which the wire here just goes up the middle, and it's what connects to the touch sensor at the top. So I just touch the sensor, and it'll turn on the white lights. These are the warm light. If I tap and hold, I can dim these down. As you can see, each one can be dimmed down separately, so you can have different brightness levels for the white and the warm white and the cool white. So here's the warm white lights. I'm tapping it with my finger here. Warm white lights. It's hard on the eyes to look at these things too. So you got 6 of them. They're 1 watt LEDs, so it draws 6 watts on each of the 2 white levels, and 3 watts on the color changing, because these are all 1 watt LEDs. So you got 3 1 watt RGB LEDs plus 6 1 watt white LEDs, and you can only have one set of them on at once. So there's the warm white LEDs. Those are the cool white LEDs, and of course we'll dim these ones down so that they don't overwhelm the camera. But here are the color changing, which are just got 3 LEDs. They got a red, a green, and a blue in each one. If I zoom the camera in a little closer, you'll see the colors changing. Still overwhelming the camera. Let's just dim them down a little more. I think I can dim down lower here. And if you double tap, it'll hold the light. So if I double tap, it'll hold it at the blue. There's 2 blue chips, 2 blue diodes on each of these. I don't know if I can get the camera to I'm just going to try adjusting the exposures so you guys can see the individual light chips. So let me find my exposure control here. Somewhere in here there's an exposure control. Okay, so now I've turned the exposure down so you can actually see what's going on inside these. If I double tap, they'll go back into the cycling color mode. So now the green LED is coming on. As you can see, we've got a green and a blue, and now the red is starting to come on. The red LED is in the middle. So now I got the green and the red running. And now the blue. That looks blue, but I think it's actually green. It just hasn't overpowered it yet. Yeah, that's a green LED. It's just that when it first lights up, it actually looks blue, not only on camera but to the eye, because that's the green one. So got a green LED along the edge of it, a red LED in the middle, and a blue LED along the center circumference. As you can see, the 3 lights are now cycling. And these are hard to look at. They're hard on the eyes, that's for sure. And they're not even turned up. They're on the dimmest setting. If I crank these up, they're actually too bright to look at now with the bare eye. It's blinding. If you look at these you'll see little spots. So I'm kind of holding my hand in front of my eyes here so that I don't have to look at them, because they are very intense when you're looking at the actual LED chips on these color LEDs. But if I double tap at a specific color, like say when it goes to green, oops, didn't quite get it. There's a bit of red there, but if you double tap, it'll hold it at the color that it's at. And the next time you go back to that, it'll start color cycling, I believe, again. Yep. So every time you turn the color cycling on, it's going to start the color cycling. So let's take a look at the control circuit. Just unplug this again. Set that aside. Let's get a close-up of this. I can't see this. I'm seeing spots from looking at those stupid LEDs. Man, those things are bright. So here's a close-up of the circuitry. Power inlet is over here. It's filtered by this 100 microfarad 16-volt capacitor. A couple of resistors over here. These are going to be buck converters to step the voltage down, because the voltage coming off of the adapter, I believe it was 12 volts. 12 volts at half an amp. So LEDs aren't going to take 12 volts to operate. The voltage is going to be stepped down. So we've got a couple buck converters in here that's going to reduce the voltage. Either that or they're boost converters and they're running the LEDs in series, which may be the case. Let's just take a look at how these LEDs are actually wired. We can see this here if we look. We'll see how the LEDs are wired. But it looks like, it probably is a boost converter, because the LEDs appear to be wired in series. If we look closely, we can see the wire going into here and then going from one over to the next. They're not wired in parallel. Don't appear to be wired in parallel, because this land here goes to this LED, and then this one here goes all the way around. Got one here and one there, and then these are connected together. You can see them here. Another one here that's connected to this one. This LED connects over to this one, which connects over to this one. See, the LEDs themselves are all in series, which is like a conventional LED lamp. So if the average LED is going to take 3 volts, so you get 3, 6, 9, 18 volts is what's going to be required to power these LEDs up. The source is 12. So this is going to be a boost converter required to step the voltage up to drive the LEDs at their maximum brightness. And they're also likely pulsed, as opposed to running them on DC. They'll be pulsing them. And the boost converters, you can see the circuitry here is connected directly over to the socket that goes over to the LEDs. I would imagine this is to control the light for the 2 white LED circuits. The color changing LEDs, on the other hand, look like they are going directly over through these resistors here. If we look at the traces here, all 3 of them go to different resistors. Looking at the configuration, these are 24 ohms, 2 4 followed by a 0, so like multipliers is 0, so 24 ohms. 101 is 100 ohms. You got 1 0 plus the multiplier 1, so 1 extra 0, so 100 ohms. These two are in parallel with each other, which would give 50 ohms here, and these ones are not. So 24 ohms on 2 of the channels and 50 ohms on the third. And that's probably because one of the colors doesn't require as much current as the other two. I think the blue and the green probably are being given a little higher current than the red. Red LEDs tend to take less of a voltage drop on them. But you can see the three outputs here go down to 3 outputs on the connector. Then you've got 2 additional ones for the other lights, and there'd be returns and grounds and stuff, right? You have ground and a return. Probably a ground for the white LEDs and a ground for the RGB LEDs, I would think. So we got two for the warm white, two for the cool white, a ground, and then RGB. And I'm just wondering if the RGB lights are connected in parallel. They look like they probably are connected in parallel with each other. And they're just fed a lower voltage. Other side of the board, of course, has got nothing on it. Just a completely blank board, other than the plating through for connecting. In place of jumper wires, they've plated it through. So I think if we look at this third connector over here, it's plated through onto this side, so that's a ground. Right? It'll be plated through underneath here. You can see, if you look on the third or fourth terminal over, you can see, looks like copper trace is running back this way, and if we look directly underneath there, you'll see that there's a plating through right here. And of course the controller IC here. Of any number on this thing that we can see. Let me see if I can get some light on there, if we can pick up a number. Looks like the number has been removed. If there was a number on there, I certainly can't see one. Either on camera or looking at it directly, I don't see a number on that IC. Interesting. So it's like they've washed the number off of it. That used to be a trick that used to get used a lot by companies that were using a pretty common chip, and they didn't want their competition making a copy of it, is that they would sand off the numbers of the ICs. That was really common back in the days of the copy guard busters for VHS tapes of the day. The macro stabilizers too, but prior to Macrovision, they used to just reduce the sync, the vertical sync blanking level. They would chop out a good portion of it, and it would cause the TV to roll. That was before Macrovision, and companies came out with these little boxes that it basically had a vertical stabilizing control on it that would regenerate the pulse train. And they would sand the numbers off them. I saw a few of those way back. In fact, the first one I wanted to build, I went and found one, and I was going to copy the circuitry because it was pretty simple. Until I got into it and found that the ICs had their numbers. Turned out to be, it was just like a transistor array with like 6 transistors inside it on a DIP package. But who would know that? You could build the thing using just 6 transistors, but they had it in a package that nobody would know what was in there. You didn't know what it was. What it turned out to be, it was just a transistor array. Real common chip that was like $1, and you could just do it with like 6 transistors. And that was the way that they tried to keep their circuitry private, was by sanding off the numbers. Looks like they're still doing it, because I don't see any numbers on this one. Before I put it together, as my camera continues to move on its own here, I just wanted to point out that the control IC here is driving transistors over here. These are the control lines here that go through the board and pop up again on this side. These are controlling these transistors, which are doing the switching for the red, green, and blue. So here's the outputs, right? You got a red, green, and blue output from the IC. So it's just an analog IC that's changing voltages to turn on the transistors to control the brightness of them. over here, switching through these transistors and then through the current limiting resistors over to the LEDs. Pretty simple circuit. I think that's what we're doing here. Obviously, I don't have a schematic, and I'm not gonna draw one out because I don't know what the IC was. If we knew what this IC was, we could easily draw a schematic out from this thing and see what makes this thing tick. But anyway, a pretty simple little circuit, and looks to be actually fairly well built. I don't see any discrepancies, and there's no batteries in this thing. It's not like some of these ones that have a battery in them that you have to worry about a lithium battery overcharging and stuff. This is just a straight AC powered, well, not AC, DC powered light that's powered from a 12 volt half amp power supply. Let's put it back together. So first we'll remount the light tower, which incidentally has just got some diffractors in here. This is kind of neat the way that this operates, because as you know, the light is going to be stronger at the base. So what they've done here to diffuse the light into the diffusion tube is they've put increasingly larger holes to block the light, because otherwise the light would be brighter at the bottom. So they want the light to be equally distributed through the entire tower. So they've put smaller lights at the bottom. Just like that. We'll put the light tower back on and fasten it down. So the first thing I got to do is now this is going to be more difficult than it seems, because I actually have to thread this wire down through this light tube and get it through the hole on the bottom, which is probably going to be a little more of a tall order. It might have been easier for me to thread a wire up from the bottom, attach it to this, and use it to pull the wire back down. And in case you guys are wondering how I'm going to pull this off, I'm going to fish some solder up through the base and get that out through the top. Solder being relatively flexible, I should be able to hit that hole on the top there, no problem. Get the wire out the other end. We'll use this to tie onto this wire. Easy peasy. One of these was smaller than the rest. It was that one. Should be able to line that up. Pop those all in. Easy peasy. Now watch me have dirt inside here that shows up on the inside of the tower. Oh, I already do. I already have a piece of dirt that's gotten down. Maybe it'll drop out when I tap on it. Because this is actually a 3-piece unit. This is an acrylic outside, and then there's the deflector in the middle there. It looks like I got some dirt that dropped down. Oh well, I'm sure it'll clear. Next, we'll put the circuit board back on and resolder the wires, and then reattach the board to the base. And plug it in and watch it blow up. I know I've probably put half of you to sleep by now, right? I mean, how much time can we spend looking at a light? Evidently, too much time. funny that the wire appears longer this time than before. I guess they had shoved some of the wire back inside the amp itself. And then it just goes together kind of like that. And we'll put the screws back into the base. Oops. Well, I may have to do some work on this. It didn't go quite back together properly, but you get the idea. We'll fix that. It works. Back together working. I just have to fix the base here. I'm not quite straight. We'll fix that. So there it is, back together, the Loftek Model W1 touch control table lamp. Warm, cool white, color changing. Links in the description. Thanks for watching. We'll catch you again in the next one real soon. Bye for now.